Hello dear students, in this session we will try to understand about one of the nuclear radiation detector, that is scintillation detector or the scintillation counter. So in this nuclear instruments section, in our previous discussion we have studied about one of the nuclear radiation detector, that is Geiger-Müller counter or the GM counter. In continuation with that nuclear radiation detector study, in this session we will try to understand about this scintillation detector or the scintillation counter. In that we will study about the principle of this detector, the construction of this detector and how this detector works. So we will discuss about all these concepts in today's session. A scintillation counter or a scintillation detector is a radiation detector which uses the effect known as scintillation. So this is the radiation detector and it uses the effect of certain phenomenon known as scintillation. So what is scintillation? Scintillation is a flash of light produced on a transparent material by the passage of a particle. So that particle may be electron, alpha particle, a ion or high energy photon. So when these particles passes through a transparent material, there will be production of certain flashes of light. So those flashes of light are called as scintillations. So how these flashes of light are produced? So when certain high energy photon or any other particle passes through certain transparent material, those particles have sufficient energy to interact with the molecules of that transparent material. So because of that interaction, the electrons present in that material will be excited or will be moved from valence band to conduction band, or else the electrons will be excited from ground state to excited state. So those electrons which are in excited state or else in the conduction band will come to the ground state or to the valence band. So while de-excitation of the electrons means from coming from that excitation state to the ground state, there will be emission of certain photons or emission of certain flashes of light, and those flashes of light are called as scintillations. So this scintillation detector or scintillation counter works on the principle of this production of flashes of light called as the scintillations. So scintillation occurs in a scintillator, which is a key part of the scintillation detector. So this scintillator is the key part or important component of this scintillation detector. So in this scintillator only, this flashes of lights or the scintillations will be produced through that de-excitation of electrons, or else traveling of electrons from that excited state to ground state, there will be production of these flashes of light called as scintillations. So in general, this scintillator or scintillation detector or scintillation counter consists of two main components. One is scintillator. A scintillator generates the photons or the flashes of light photons in response to the incident radiation. So in response to that incident radiation, this component, that is scintillator, produces or generates certain light photons. So this is also one of the important component of this scintillation detector. Apart from this scintillator, there is one more component which is called as photo detector, a sensitive photo detector. So photo detector means it detects the photons or it detects the flashes of light produced in that scintillator. So that photo detector may be a photomultiplier tube, PMT, a charged coupled device, CCD, a photo diode. So that photo detector may be any one of these. Generally, in this scintillation detector, the photomultiplier tube is used as the photo detector. So we have scintillator and the photomultiplier tube as the photo detector, and this photomultiplier tube converts the light to an electrical signal. So the role of or the function of this photo detector, or to be specific, the role of the photomultiplier tube which is present in this scintillation detector is to convert the light pulse into an electrical signal. So that electrical signal can be amplified using certain electronics components such as amplifiers, that is preamplifier as well as linear amplifier. So those amplified electrical signal will be processed in order to determine the energy as well as intensity of the incoming radiation. So the basic or the main components of this scintillation detector are: the first one is scintillator, which generates the photons in response to the incident radiation. Then another one is the photo detector. So the commonly used photo detector is the photomultiplier tube. So using that photomultiplier tube, we can convert the light signal into the electrical signal, and that electrical signal will be processed to get a good amplified or good will be amplified to get a good pulse in response to that incident radiation. So that amplified pulse will be responsible for that incident radiation energy as well as intensity. Means by recording those electrical signals or pulses, we can determine the energy as well as intensity of the incoming radiation. So this is the construction or the main components of this scintillation detector. One is scintillator, another one is the photo detector. So this is the block diagram of this scintillation detector. At first we have scintillator, and after that we have photomultiplier tube as the photo detector. So in that photomultiplier tube we have photocathode, the focusing electrodes, a series of electrodes called diodes, and at last we have the anode. So when the photon or any light photon incident onto that scintillator, then there will be production of the flashes of light called scintillations. Those scintillations are made to incident on the photocathode of the photomultiplier tube. So when these scintillations incidents on that photocathode, from that photocathode there will be ejection of electrons through the photoelectric effect. So we all know that the photoelectric effect is when any light radiation incident on certain material or metallic surface, that light radiation or photon has sufficient energy to eject the electrons from that metallic surface. Then there will be ejection of electrons from that metallic surface, and this process is known as photoelectric effect, and the electrons ejected in that process are called as photoelectrons. So these scintillations or flashes of light have sufficient energy to eject electrons from that photocathode when they made to incident on that photocathode through this photoelectric effect. So from that photocathode there will be ejection of photoelectrons. We can call them as the primary electrons. Then with the help of the focusing electrode, those primary electrons are made to incident on the first electrode called as diodes. So these primary electrons have sufficient energy to eject the secondary electrons from the first diode D1. So if the one electron is made to incident on that diode, suppose that primary electron has sufficient energy to eject one more electron which is called a secondary electron from that first diode. So in the first diode we have two electrons, one is primary electron and another one is secondary electrons, and those two electrons are made to incident on the second diode. So again those two electrons have sufficient energy to eject some of the electrons from the second diamond. For example, 2 is converted into 4. So again those 4 electrons are made to incident on the third diamond, so that in this photomultiplier tube the photon multiplication takes place. That's why it is called as photomultiplier tube. So in this process, one primary electron is converted into a large number of electrons which are collected at the anode. So the electrons collected at the anode will be processed with the help of certain amplifiers, and these electrons or these signals collected at the anode have sufficient information about the energy and intensity of the incoming radiation. So this is the construction, working as well as the principle of the scintillation detector. It has scintillator and it has photomultiplier tube. In that photomultiplier tube we have photocathode, series of diodes called as diodes through which the electron multiplication takes place and the electrons will be collected at the anode. So this is the block diagram which explains the principle as well as construction and working of this scintillation counter. So the basic principle of operation of this scintillation detector involves the radiation reacting with a scintillator which produces a series of flashes of varying intensity. So it produces a series of flashes of light with variable intensity. So the intensity of the flashes is proportional to the energy of the radiation. So this intensity is directly proportional to the energy of the incoming radiation. So this feature is very important so that these counters are suited to measure the energy of the gamma radiation. So because of this reason, we can use this scintillation detectors in the gamma spectroscopy. Therefore, it can be used to identify gamma emitting isotopes. Means we can measure the energy as well as intensity of certain gamma radiation emitting isotopes. So for that purpose, we can make use of this scintillation detector. So the operation of this scintillation counter is summarized in the following points. So far we have discussed the working of this scintillation counter. It is summarized in the following points. The ionizing radiation enters the scintillator and interacts with the scintillator material. So this interaction causes electrons to be raised to an excited state. So because of the interaction between incident radiation and the scintillator, there will be moving of electrons from the ground state to the excited state. So if the incident radiation are charged particles, then for such charged particles the track is the path of the particle itself. So for the charged particle, the track is the path of those particles itself. Suppose if the uncharged particles such as gamma rays enter into this scintillator. So for gamma rays, their energy is converted to an energetic electron via either the photoelectric effect, the Compton effect or Compton scattering and the pair production process. So for the charged particle, the track is the path of those charged particle, but for uncharged particles such as gamma rays, the energy of such gamma rays is converted into energetic electrons through main three processes. One is photoelectric effect, Compton effect and the pair production. It means the interaction of gamma radiation with the matter is mainly through these three processes: photoelectric effect, Compton effect or the pair production. By understanding these three processes, we can understand the complete gamma ray spectroscopy or gamma spectroscopy. So the excited atoms de-excite and rapidly emit a photon in the visible or near visible region. So the quantity is proportional to the energy of the incoming radiation or ionizing particle. So the excited state comes to the ground state with the emission of certain flashes of light called as scintillations in the visible or near visible region. So this quantity is proportional to the energy deposited by the ionizing particle. So the light created in this scintillator strikes the photocathode of the photomultiplier, releasing at most one photoelectron per photon through that photoelectric effect. Using a voltage potential, the group of primary electrons from the photocathode is electrostatically accelerated and focused so that they strike the first diagonal with enough energy to release additional electrons. By using certain voltage difference, the group of these primary electrons are accelerated and focused to the first dynode, and these accelerated electrons have sufficient energy to release additional electrons called as secondary electrons. So these secondary electrons are attracted and strike a second dynode, releasing more electrons, and this process occurs in the photomultiplier tube. That is, multiplication of the photons takes place. So each subsequent dynode impact releases further electrons, and so there is a current amplifying effect at each dynode stage. So each stage is at a higher potential than the previous to provide the accelerating field. Primary signal means primary electron is multiplied, and this amplification continues to 10 to 12 stages. At the final dynode, sufficient electrons are available to produce a pulse of sufficient magnitude for further amplification. So for one primary electron at the last dynode, we have sufficient electrons to produce a pulse of sufficient magnitude for further amplification process. So this pulse carries information about the energy of the original incident radiation. The number of such pulses per unit time gives information about the intensity of the radiation. So the large number of pulses recorded at the last dynode will be amplified further, and those amplified pulses carries information about the energy of the original incident radiation. Along with that, the number of pulses per unit time means per second or per minute will gives information about the intensity of the incident radiation. So this is the principal construction and working of scintillation detector, which consists of two main components. One is scintillator, in which the flashes of light produced through that de-excitation of the atoms as well as molecules. Then the second one is photomultiplier tube, in which the photon multiplication takes place, and the photons which are converted into electrical pulses will be amplified further, and those amplified pulses carries the information about energy as well as intensity of the incoming radiation. Likewise, many instruments or many detectors. So this scintillation detector has certain advantages as well as disadvantages. So what are the advantages of scintillation detector? Are the scintillation counters are widely used in radiation protection, assay of radioactive materials and physics research, and this is because they are inexpensive, because they can be made inexpensively yet with good efficiency and can measure both intensity as well as energy. So what are the advantages of scintillation counter? They are inexpensive, good efficiency, and using this scintillation counter one can measure both intensity as well as energy of the incident radiation. So these are the some of the advantages. Then what are the disadvantages? One of the main disadvantages is hygroscopicity. Hygroscopicity means hygroscopic means when these scintillations means in scintillators we have different types. To be specific, some of the inorganic scintillators such as sodium iodide crystal, that is NaI crystal, which is activated with certain thallium. So such scintillators are hygroscopic, means they will absorb the surrounding moisture. So in order to avoid that hygroscopic nature, we should place these scintillators in certain aluminum cans or aluminum containers. So that is one of the disadvantage, that is hygroscopicity or hygroscopic nature of this scintillator. A disadvantage of some inorganic crystals such as sodium iodide is their hygroscopicity, a property which requires them to be housed or to be kept in an airtight container to protect them from the moisture. So hygroscopic means these scintillators absorb the surrounding moisture. In order to avoid that, these scintillators must be placed in certain container or aluminum can. So it is one of the disadvantage of this scintillator or scintillation detector. Along with that, the sodium iodide crystal, which is the commonly used scintillator in most of the scintillation detector. So this thallium activated sodium iodide has no beta or alpha response, means the response time for this beta and alpha for this thallium activated sodium iodide crystal is very less. It has no beta or alpha response and poor low energy gamma response, means using this we can able to detect the high energy gamma photons, but this detector has low resolution for the low energy gamma photon. So these are the two disadvantages. One is hygroscopic nature and another one is no beta or alpha response along with poor low energy gamma response for this inorganic type scintillator. So these are the two advantages and these are the two disadvantages, and advantages are these scintillation detectors are inexpensive, good efficiency, and it can be used to measure both intensity as well as energy of the incident radiation. So the summary of today's session is, in this session we have discussed about the principle, construction, working, advantages and disadvantages of the scintillation detector. So this completes the study of nuclear detectors. One is GM counter and another one is scintillation counter or the scintillation detector. So in this nuclear instruments only, in our next sessions we will discuss about the particle accelerators. One is linear accelerator and another one is cyclotron accelerator. We will discuss those two concepts in the next sessions. Thank you.